Hi, so this is how we are going to solve problem 17 on page 115. We figured out that we're going to use Newton's second law and the time-dependent kinematic equation, velocity equals initial velocity plus acceleration times time. Notice that we're using the x subscripts here because the block is only moving left and right. We're not going up and down, we don't need to worry about vectors or anything like that. We have our two equations, and we also have two unknowns, which is nice because we can solve this problem. Acceleration, we're going to need to find that. That's what part A is asking for. And part B is asking for the velocity when the time is at 6 seconds. Notice that we're going to need to use this acceleration as well for the second equation. It's right there. To solve for that velocity when t equals 6 seconds. First step, we're going to isolate the acceleration in Newton's second law. Second, we're going to plug in our known values to find acceleration. Our known values are the force applied, the lack of friction, the mass, and we're also giving that time that we'll use later. And number three, we're going to substitute that value that we found, the acceleration value that we got in step 2, and also plug in 6 seconds for t and the velocity equals initial velocity plus a times t equation. And please note that, again, this is all in the x direction. It's going to be pretty straightforward. First step, we're going to isolate acceleration in Newton's second law. Notice that this symbol means change in. So we're talking about a change in forces. Our two forces are going to be the force applied on the block and kinetic friction. However, the problem does note that there's no kinetic friction on the surface. So our kinetic friction coefficient is going to be 0. There's no friction going on. So that'll just be 0, and we just have the force applied. We isolate acceleration, and we should get the force applied over m equals acceleration. Second step, we're going to plug in our known values to find acceleration. We have force applied over m equals acceleration in the x direction. We know that the force applied is 30 newtons, and the mass is going to be 8 kilograms. And our acceleration is going to end up equaling 3.75 meters per second squared. Quick side note, this slide is going to be different from the original slide. I made a quick typo. I accidentally said 80 kilograms, but it's actually 8 kilograms. Number 3, substitute the acceleration value and also t. We're going to have t equals 6 seconds. We're going to put that into our second equation, the kinematic time-dependent one. Velocity equals initial velocity plus acceleration times time. So we can plug in our known values. We are assuming that the block starts out, the initial velocity is 0 meters per second. We know our acceleration, 3.75 meters per second squared, and we're solving for the velocity at t equals 6 seconds. We can do this, and we should get velocity in the x direction equals 22.5 meters per second. So the answer to part A, the acceleration of the block, was 3.75 meters per second squared, and the velocity when t equals 6 seconds is 22.5 meters per second. Thank you.